Hello guys, good morning, good afternoon, depending wherever you are on my channel. I'm welcoming you back to Applied Science College channel. Today we are going to learn titration, chemistry practicals, and the topic is titration. So we are just going to carry out a simple titration here of sodium hydroxide and hydrochloric acid. Let's start. So first of all, we are going to fill the burette wheel with the hydrochloric acid. But first, before we do that, we are supposed to rinse the burette with a little bit of hydrochloric acid. Make sure you use the funnel so that you avoid some solutions splashing to the sideways. So we are just rinsing the burette with a little bit of the solution of hydrochloric acid so that it does not interfere us with the molarities. We are not supposed to rinse with water because water will dilute more the solution that we are supposed to use, which is hydrochloric acid. It will interfere with the number of moles. Right? Okay. Now we return the burette back onto the stands. Make sure we just tie it firmly. Then we fill the burette with hydrochloric acid. We are supposed to fill the burette with the hydrochloric acid like that, up to the 0 mark. So this is our 0 mark. In fact, we are very much accurate. It is on the 0 mark. Then we are supposed to pipette sodium hydroxide solution into the conical flask. You just be very careful so that you don't take it in your mouth. So you make sure it is on the mark. The mark 25 is just located. It's just marked below. It's on this graduation. Yes. So we are putting it on the conical flask, like that. Make sure the last drop enters into the conical flask, like that. Then we are supposed to use as our indicator, phenolphthalein indicator. So we are putting 2 to 3 drops. This is the color of sodium hydroxide. When an indicator is put, it appears pink. So we are going to titrate it against the acid that is in the burette. Let us start. So since this is the first trial, you are just supposed to run the solution very fast like that, so that you first see where it will change it, where it will neutralize the sodium hydroxide in the conical flask. So you will run it just very, very fast, like that, until when you start seeing slightly color change. Because it's supposed to turn to colorless. That is our expectation color. So you continue titrating until when you will start seeing some slight changes in the solution. That's when you will start slowing down for you to save time. For example, I've started seeing some slight changes in my conical flask, so I'm supposed now to start dropping it drop by drop. Like that. Wow, the color has changed to colorless, as you can see. Now we come back to our burette. So it has changed at 23.8. So we are coming back here. First of all, this is the procedure. You are provided with 0.1 molar sodium hydroxide. Our 0.1 molar is there, sodium hydroxide, and then hydrochloric acid solution of unknown concentration. We don't know its concentration. And we have used phenolphthalein indicator. You are required to standardize hydrochloric acid using sodium hydroxide. So we have done the first titration. So we are going to tabulate it on this table here. Here it's the final burette reading and then the initial burette reading. Initial burette reading was 0.0. So we write here 0.0. Now, the final burette reading here, we have found it to be 23.8. So we come and write here 23.8 like that. Then we carry up the second titration. So we are still just going to refill the burette back to 0 mark. We refill the burette with the hydrochloric acid up to the 0 mark. Like that. Yes. Then from there, we just pour away this solution and then we pipette again. This is our sodium hydroxide. So we are on the second titration. So we are exact. We put it in the conical flask like that. Make sure the last drop enters into the flask. Then from there, we put 2 to 3 drops of phenolphthalein indicator. 1, 2, 3. Yes. Then we do our titration again. Since we have known that where it changes, the turning point, it will be around 23 to 24 there. You are not supposed to waste time. You just release the solution very fast like that. Very fast like that, so that you can also save time. Ensuring that all the drops enters into the conical flask. But it's not supposed to enter onto the walls of the flask. It is supposed just to go direct into the solution. Until when you will reach at a point there around 20, that's when you can start dropping drop by drop, like that, as you go by. So that you can get the accurate results of the tighter volume. Wow. You can see our solution has turned colorless. So we go back to the burette reading. It is 23.5. So we go back to our table here. We write 0.0, then 23.5. We do the third titration again. We refill the burette up to the 0 mark. our hydrochloric acid in the burette. So you make sure that you are very accurate. Sometimes if you make an error of protruding to the zero mark, you reduce the solution until when it coincides. The law means coincides with the zero mark, like that. Then you pour the solution away. You make sure the conical flask, even at the outside, it's supposed to be very clean so that when you're carrying out the titration, you can be able to mark the end point very fast. So we pipette the sodium hydroxide again, 25 cubic centimeters in the pipette. We just release a little bit until when you will reach the mark. Yes, this is the mark. You put it in the conical flask, like that. You make sure that the last drop enters into the conical flask, and then you put the phenolphthalein indicator. 1, 2, 3. Then we do the third titration. Since we have known that it's supposed to change at 20 to 23 there, you will just release the solution like that. Like that, like that. As you sway, you make sure that all the solution reacts, mixes with the sodium hydroxide. Hydrochloric acid mixes with the sodium hydroxide in the conical flask. When you reach around 20 to 22 there, you reduce your speed of the solution that is being released from the hydrochloric, from the burette. So you just put drop by drop until when you reach the end point. Like that. You put a drop like that. Wow, it has changed already. So here it is 23.5. So we write 0.0, then 23.5. So here there is final burette reading, initial burette reading, and then the volume of the acid that has been used in the burette. So here we just take 23.8 minus 0. We get 23.8. Here we subtract the final burette reading from the initial. 23.5 we subtract from 0, we just get 23.5. The next item, the last item volume, we do the same and then we get here 23.5. So the volume of the acid used. Let us just go back to the question. The question it is asking, determine the number of moles of hydrochloric acid used determine the number of moles of sodium hydroxide solution in the solution that were used. So in this case we are just going to write the equation. First of all, let us calculate the average volume. Average volume of the acid used is equals to first reading plus second reading plus the third reading. Divide by 3, both are supposed to be cubic centimeters. So it's going to be equals to 23.5 plus 23.5. So we take plus, this is supposed to be 23.8 plus 23.5 plus 23.5. Divide by 3, which is going to give me, if we can calculate this, it's going to give me 23 points. 23 points. Let us say something to do with the 23.6 cubic centimeters. For example, now we are going to, the question also asks, write the equation for the reaction. We are supposed to determine the number of moles of sodium hydroxide. So we are going to write the equation for the reaction. Sodium hydroxide plus hydrochloric acid is giving us sodium chloride plus water. Liquid aqueous. Mole ratio is 1:1. Rarity. Here with the sodium hydroxide we have been given, it is 0.1. But with the acid we have not been given X. So we have been asked to determine the number of moles of sodium hydroxide. So we are going to do this. Since we know the concentration of this sodium hydroxide, it is 0.1 molar in 1,000 cubic centimeters. Let us say now, maybe we got here 23.5 in all places. So our average volume will give us what? 23.5. So we are going to get here. We are going to get, like for example, our average volume. If you want to get the number of moles that were in this sodium hydroxide, they are supposed to be 23.5 in cubic centimeters. So we are calculating the number of moles that were here. So we are going to cross multiply to give us 0.1 times 23.5 divided by 1,000 cubic centimeters. All these are supposed to be the number of moles in 23.5 cubic centimeters. These are the number of moles. So I hope we will come back with more chemistry practical class for the titration, for the procession from where we have stopped. We will be able to determine the number of moles of the hydrochloric acid that also were used, and we shall also be able to determine the molarity of hydrochloric acid that were used. So we will come back to you with more practical classes. See you in the next virtual practical class. Remember to like, to subscribe, and to share my channel. Otherwise, thank you very much.